Hello everyone. Today we are getting into a new lesson on perimeter and the coordinate plane. So here we're really going to be using everything that we've learned with finding the length of a segment from the previous lessons. So for number 1, I am given the coordinates or the vertices -2, 3, 3, -3, and -2, -3. And I want to find the perimeter of the polygon with these given vertices. So my first step is to go ahead and plot those vertices. So I have -2, 3, so left 2, up 3. And then I'm going to go ahead and label it, so that one is A. B is at 3, -3, so right 3 and then down 3. And then C is at -2, -3, so left 2 and then down 3. So I end up with this triangle here. And I want to find the perimeter of this triangle. So if you remember, perimeter just means that you're adding up all sides. So let's write that down. So perimeter equals add up length of all sides. So looking here, I have a triangle and I see that for 2 of these, I can automatically find the length of them. So I see that for AC and CB, since this AC is vertical and CB is horizontal, I can just count those boxes to see what those lengths are. So for AC, for example, that is 1, 2, 3, 4, 5, 6. And then CB is equal to 1, 2, 3, 4, 5. But now I get to AB, and this one I can't just count because it's diagonal through here. It's not those perfect boxes like we had for the others. So there's a couple of different ways that we can do this. We can use the Pythagorean theorem like we've used before to find the length of AB, or we can use the distance formula to find it. So just to get some more practice with distance formula, I'm going to go ahead and use distance formula for this one, and then for another problem we'll show an example of using the Pythagorean theorem. So I'm finding the distance between A and B, so that's going to be these 2 points here. And remember, my distance formula is x2 minus x1, so I'm going to go ahead and label my x1 and x2. So my first point A is just going to be labeled x1, y1, and then B is going to be x2, y2. And so for my distance formula, which I can go ahead and write up here, remember the square root of x2 minus x1 squared plus y2 minus y1 squared. So here my x2 is 3 minus my x1, which is -2, plus y2, which is -3, minus y1, which we have as 3 squared. And now we need to simplify this. Well, 3 minus a negative, that's really just saying 3 plus 2. So I have 5 squared plus -3 minus 3 is -6 squared. When I do 5 squared, that's 5 times 5, which is 25. And -6 squared is -6 times -6, which is 36. And then when I add 25 and 36, I get 61. Now I need to see if I can reduce that further, but you'll find that 61 is actually a prime number. So the only numbers that multiply 61 are 1 and 61. So this is completely simplified. So now that I have all side lengths, I have 6, I have 5, this is the square root of 61. To find the perimeter, all I need to do is add those all up. So I have the perimeter is equal to 6 plus 5 plus the square root of 61. And as we recall from our operations radicals, I can only combine like radicals, so the only thing here is I can add 6 and 5. And so my answer becomes 11 plus the square root of 61 units. Okay, let's try another one. So here I have the shape KLMN with these coordinates. So this one has 4 coordinates. This time we're going to get some type of quadrilateral. So first I'm going to plot those points. So I have K, -1, 1. L, 4, 1. M, 2, -2. Down 2, up, right 2, and then down 2. And then N, -3, -2. And so I end up with this quadrilateral, which we'll learn about later is actually a parallelogram. So I see for this one, I have 2 side lengths that I can automatically find the length of. I see that KL, I can go ahead and count those. And I see that's 1, 2, 3, 4, 5. And NM is 1, 2, 3, 4, 5. So automatically have those. Now I need to find the length of KN and LM. So let's start with KN first. I will go ahead and use the distance formula for this one. And then for LM, we'll go ahead and do that with the Pythagorean theorem so we can see both ways. So for KN, I'm going to first go ahead and label my x1, y1, x2, y2. So I'm going to have K be the x1, y1, N be the x2, y2. So I have that Kn is equal to the square root of x2 minus x1, so I have -3 minus -1 squared, plus y2 minus y1, so -2 minus 1 squared. Well, I have -3 minus a negative number, so whenever I'm subtracting a negative number, I'm really adding a positive. So I have -3 plus 1 to get -2 squared, plus -2 minus 1 is -3 squared. -2 squared, that's just -2 times -2, and I get a +4. -3 squared is -3 times -3, which gets me a +9. And so I get the square root of 13. 13 is prime, so I can't reduce this radical any further. Okay, now for LM, I'm going to go ahead and show that with the Pythagorean theorem. So if you recall, when we have these coordinates, I can go ahead and make a right triangle by doing some of these dashed lines here. Let's add that there. And so that I'm going to be using a squared plus b squared is equal to c squared. And so I see that my a is length of 2, so I have 2 squared. My over here is 1, 2, length 3, so I have 3 squared is equal to c squared. 2 squared, I get 4, plus 3 squared is 9. 4 plus 9, I get 13. And I take the square root of both sides, and I get that the square root of 13 is equal to c, which is just my LM. And so I see I end up actually getting the same answer there. And so that means that my perimeter is going to equal to adding all 4 of these lengths up. So I have 5 plus the square root of 13 plus the square root of 13. So 5 plus 5, I get 10. Square root of 13 plus square root of 13, I get 2 square root 13 units. Okay, Okay, let's look at one last one. So here I have G, H, J. So I know I'm going to get a triangle for this one. G is at -4, -3. So 1, 2, 3, 4, 1, 2, 3. H is at 4, -3. So 1, 2, 3, 4, 1, 2, 3. And then J is at 1, 3. Okay, so for this one, I see that I only have one length that I can automatically just count, and that's this base down here, my GH. And I see that's going to be 1, 2, 3, 4, 5, 6, 7, 8. But now I need to find GJ and JH. So GJ, I'm going to go ahead and use the Pythagorean theorem for that one. And so when I do that, I'm going to make myself a right triangle. And I see the length of this side is 1, 2, 3, 4, 5, 6. The length of this side is 1, 2, 3, 4, 5. And I want to find the length of GJ. And so I use a squared plus b squared is equal to c squared. My a I'm going to have as 5, so I have 5 squared plus b, which is 6, 6 squared. So I have 25 plus 36, which ends up being 61. And then I can take the square root of both sides, and I get that square root of 61 is equal to GJ. Okay, go ahead and pause the video. I want you to find the length of JH. You can use either the Pythagorean theorem like I did on this first one, or you can use the distance formula. I'll go ahead and show the distance formula when you press play. So the answer you should have gotten for h to j was 3 square root of 5. So it should have had square root of 45, but that one could be simplified further because of this 9 here, and so you should have gotten 3 square root of 5. And so that means that my perimeter is going to be 8 plus square root of 61 plus 3 square root of 5 units. I can't simplify that any further because these are not like radicals.